Like I said, we're going to be talking to Tony. And the first question for you, Tony, is what challenges are you seeing for broadcasters today?
Well, I think, with COVID, I think that happened. A lot of the things that we've learned painfully fast, and maybe not the best way, is nobody's in the building anymore. And we have all these huge 25,000 square foot, 50,000 square foot buildings. Down here, SBS has this huge property that there's like 13 people in. And we have to create remote studios on the fly via IP, dealing with every type of connection there is. DSL, someone's running, a satellite at their house, or Comcast, or you're running a Max Connect card or 4G LTE. I think that's what we've learned, is had to bob and weave as engineers really fast to be able to get remote broadcasts on the air and get our talent, whether it be radio or television, back on. And then the back office stuff. A lot of places didn't have VPNs in place where they can send traffic home, and traffic directors and everybody else. And you're used to be maybe the salespeople, but now nobody's in the building. So I think that's what we've learned during the last year, painfully. That's the biggest challenge. And now it's cost reductions. Now that everybody learned that we can work from the house and we can cut costs that way and make full-time employees part-time employees, we don't need these big buildings anymore, but we need the infrastructure that can support having 30 people work from the house. So now it's the infrastructure and cost cutting to get that up and running. So it's been an interesting year, I know, for us, and it's been an interesting year for all the broadcasters I spoke to.
Yep. All right, so those are some of the challenges. How about connection types? What kind of connection types are you seeing available? And this one, guys, sometimes that's why I like having these meetings, is because we're in all different places, or in terms of where you've worked over the past years and what kind of services are available, from rural to highly urban areas. What are you seeing out there, Tony, in terms of connection types?
We're still dealing with the people who have T1s in place that now are starting to really feel the pain when a T goes down or a DS goes down, a DS0 goes down. Now they're trying to find someone who knows how to work on it to get them up and running again. And IP is becoming so prevalent and inexpensive. Buying a 45 meg pipe is really cheap now. Most radio facilities now have at least a multiple bandwidth pipe, 100 meg from your cable modem up and down, gig service from cable company up and down with no problem. But now we're seeing where the groups are dropping in 45 DS0s, or dropping in a 96, and having just this fat pipe sit there so they can interconnect their transmitter sites. I know a lot of the groups are now dropping, 50 meg in at transmitter sites. We can move audio across that. We can move video, compressed video across that real easily. And the one thing that's really impressed me now is, Elon Musk satellite IP. I'm on the list. Hopefully I can get it here shortly. I've tried Viasat, which works really well, but it's very limited in how much speed you can get depending on what part of the United States you're in. But what Elon Musk is going to do is just provide everybody just this fat pipe for $100 a month. And the dish is, basically the size of like a microwave, 27-inch dish or something like that, self-aligns, and it just is up and running. It's $500 in gear. I mean, $500 is nothing. So, we spend more in routers and firewalls than that just to put this up. So that's going to be a game changer, I think, for a lot of people. I think a lot of radio stations who, had relied on 950, a lot of TV stations who had TV microwaves going out to some of these other sites and trying to get up their translators and their boosters. Now, all of a sudden, you'll be able to drop this dish down and be able to get IP anytime you want. Drop multiple dishes down, you can have, multiple paths.
Okay. Cool. Are all IP connections created equal?
No.
I see a few smiles out there too. I thought that'd get a chuckle.
The one danger I'm seeing right now is misrepresentation by the telco companies, and I'm going to not mention this 3-letter carrier AT&T, that they keep representing that an SD-WAN is the next best thing since a layer 2 MPLS. It is not. An SD-WAN will get you every time. Only thing an SD-WAN guarantees you is that you have connectivity. That's great if I'm running a cash register somewhere and I don't care about the latency or the jitter or anything. But if you're trying to run video, you're trying to run audio, and you're in an SD-WAN, it's, the software defined WAN is great in a sense where it will redirect itself based on path subscription rates. But that also means 1 minute you may be on a real fat pipe, and then there's a backhoe outage and the SD-WAN server throws you on a T1. Well, if you're passing uncompressed linear audio with at 48 and you're running E2X data across there for HD, and you're running RDS and you're at 2.2 meg without your 25% FEC, you'll blow through that T1 and shut your station down really fast, even though it worked 99% of the time. So that has been an education, and that is something I've spent many a times with the radio groups on, with the higher ups walking through the issues with SD-WAN. Now you can, if you're getting an SD-WAN where you own the pipe and you're using the SD-WAN server, or if you would firewall, and you own the latency in the pipe and all that, that's great. But when AT&T says, oh, we're just going to drop off this Ethernet connection, you will guarantee connection 24 hours a day, 7 days a week, you're gonna run into issues. So that's the biggest one that I'm seeing right now, especially on the West Coast. I saw this last year in Los Angeles, dealing with a couple of groups there, in Portland, dealing with some groups there who were like, wow, they'll drop in this SD-WAN, they'll drop in a 1 gig pipe for $400 a month. And then it goes to a T1 and everything's off. So that's the biggest issue.
And one thing that you and I both worked on a project here last year with another radio group. There's actually bandwidth brokers, if you will, that go out and hunt for all these different connection types, and then they'll come back to maybe the radio group or the VP of engineering and say, "Here's what I found. Here's your rate table. Here's your whole matrix of what you can expect to save." And sometimes those savings are ghosted with services that you may not really be getting, that you think are going to take care of your IP devices.
And you have to remember, those brokers are designed for the CFO, not for the engineer.
Yeah.
Those brokers are designed to save everybody money and make everybody look good. But the way the engineer tries to get something down the pipe and you go, well, that's not what I asked for.
Yeah.
Now you have to go back to your CFO or your GM and go, well, that circuit doesn't work the way it's supposed to. So the brokers are great if you could trust them and understand and know how to read their mumbo jumbo between the lines. That takes some talent to understand a tariff. But you got to really understand the latency, the guaranteed latency, guaranteed throughput, and path redirection. That's basically what you have to.
Yep, and I'll come back to that at the end of our presentation, because it does go full circle. So, what's the number one reason for stations calling you?
They miss me. I used to be there every year, a couple of times a year, and they miss me, taking them out to lunch, taking them dinners, bringing them to Vegas. That's now it's IP connectivity. Is how do we, for the guys who are on the radio with pitcher side, is we need multiple video streams to our multiple transmitter sites. How do we do that? What can we do over IP that I can rely on, that's just as reliable as my point-to-point microwave or my TV fiber? With radio, it's the same thing. Is, hey, we're doing this. We just acquired a group of 7 radio stations, and I need to figure out how to get all of them over from point A to point B tomorrow. So that's really the calls that we're getting now, is how do we make it work, and what's your answer? How do we integrate with the GatesAir product?
Good. Okay, so you guys heard a lot from Tony and I. I thought it'd be fun to ask you guys, the audience there, and we can do this by way of hands, just so Tony and I get a better feel, because every group's different, and it all just really depends. Are you currently sending your signals via point to point? Maybe a thumbs up, thumb down. Feel free to share there on the Zoom menu. Maybe I'm not seeing any responses. No, there we go. Thumbs up visually. Okay. So a lot of point to points, it looks like. Okay. Good, good. So the girl says yes. All right, we see that. All right. How about do any of your signals need to go from studio to multiple destinations? What are you thinking there? Studio to multiple destinations. I see one,
Dave, yeah,
couple, two, three,
or
4, 5. Okay. All right. So we're gonna really be talking about both, but the second question there is kind of what we've filled the need for with some of our equipment there. So, and the reason being is, so many of these multiple destinations now are, like Tony said, it's an FM. If it's an FM and a TV station, then there you go. Or one format going from the studio side to 1, 2, 3 different locations, and how do we address that? And then the other thing I just thought of, there's a lot of shared sites, so a lot of applications there to send both. So that being said, as I initially made the comment, the Ascent Media Gateway, it's the STL for both audio and video. By way of hands, how many of you guys have IP links out there? GatesAir IP links? 2, 3, okay, a few. So the interface and the GUI is not much different, except that it's just a high density application, meaning that you can do a lot more channels, and you can also add video to that. So that's what we're going to talk about. For some of the features and under the hood stuff, I'll go back to you, Tony.
so the Ascent Media Gateway really came into play from people calling it, okay, we have your IPLs and we have the IPL 200. You make an IPL 400. You make an IPL 600. Where multiple channels, and the IPL is a great platform. It's we still working on developing feature set for it, but we needed something that would grow with us, and also grow into video platform. So, like Nick said, the Ascent and the Ascent Media Gateway have the feel, the taste, and the smell just like an IP link, where you can put in multiple addresses, multiple ports, multiple flavors of information, whether it's UDP or RTP over UDP, or if you want to use SRT, absolutely use that. Or if you want to use a combination of their SRT with dynamic stream splicing and what have you. So we could
What is
basically
SRT for those that
secure reliable transport. It's basically I had a picture of me with an Emmy with SRT. The SRT consortium for the guys who do television. Basically, it allows for high latency, high bit loss, bit loss, and still maintain a quality video signal. 2 years ago, there was the SRT row in the TV hall at the NAB, where everybody was showing 20% packet loss and high jitter rates, and before and after in the picture. We are the only ones who are running SRT for audio, so we can do secure, reliable transport. Basically, as TCP/IP, as you know, that it communicates back and forth. If you start having packet issues or you have latency problems, it will start slowing down the data rate until it gets to a point where it's able to pass clean data. If you have any kids who play any Xbox or PS4s, whatever, they call it lagging. We call it, we call it DirecTV dying again or whatever. In SRT, it doesn't. It'll maintain the speed, but it has hooks in it that will ask for retransmission. So it allows for it to send retransmission as the buffer to it, has the FEC, and then when you tie it in with our patented dynamic stream splicing, which takes multiple paths to your destination and aggregates the data between all these paths, then you're guaranteed basically no loss or very little loss and maintain a high quality. So that's unique to us. No one else is doing SRT right now that I know of, for audio, should I say? And what we really don't care. We're kind of agnostic to what we're moving from point A to point B. We're just the transmission path. We capture the package and off it goes. So we'll accept, in the Ascent, if you would, the Ascent server. AES-3, AES-67, baseband 192, analog, composite, composite being the form of the baseband 192, WheatNet, LiveWire, Dante. We are LiveWire's shipping now. WheatNet should ship shortly. And at the same point, we can ingest the UDP stream from any ATSC1 or ATS3, and we could do point to point, point to multi-point, multicast, unicast, multi-unicast with the multiple protocols. If you're sending audio, we can multi-code. We can ingest one piece of audio and send to 50 different destinations. Maybe one is uncompressed linear, one is Opus, one is G.722, one is IceCast. So we have the ability to multi-code any piece of audio that's coming in. I've got an Ascent running here at the house that I'm sending to 3 different IPL units, and so you can bring a channel in and move it to different destinations. The same thing with the Ascent Media Server. The Ascent Media Server basically is a repeater. We'll ingest information from an IP address, and again, it doesn't need to be on site. We have a media group out of Florida here who has an Ascent Media Server that is going to be sitting in StreamGuys, and that's a content delivery network. So you can sit at a StreamGuys, AWS if you wanted to, Google, what have you. It'll ingest the information, and then you turn around and send it out through multiple paths, multiple to as many different destinations as you want to. Right now, when we did this screen 3 weeks ago, we did the maximum of 300 meg per server. Now we're up to 500 meg per server. And that's really just us not wanting to overstate how much throughput we're putting through the machine. We're really conservative with that. We want to make sure that we're not breaking down a path if something starts to happen. So, but right now we could do 50 meg streams, which is ATS3, and we actually have a station in Ohio who is ingesting a multi-layer ATS3. We're binding 2 signals together into one SRT package and sending it to 2 different destinations, 2 different transmitter sites at the same time over the public internet. And it just sits there and plays. So that's really what Ascent does. We don't have any video codecs built in. We'll take a signal in from your system. We use GatesAir. If someone says, "Hey, I really need to give you, I need to give you a signal. I need to give you an SDI," and okay, fine, we can use a DECTEC encoder, and we know that works. That's one we've tested. There's Thor. There's a couple of other technologies out there. Thor is an 8-channel system, or 4 or 8-channel system that you can run. But as long as it's a UDP stream, we can accept it, send it out, and send to any destination on the other end.
Cool. So that being said, let's talk about some applications. And we really came up with this graphic so you can really see the flexibility of what you're looking at here in terms of how versatile this is. And we've kind of said it's the Swiss Army knife. What are we looking at here, Tony?
What I like about the Ascent is, again, I don't care what the package is. I could just transport it. So in a case where I'm in a mixed facility, if I'm in an FM AM television facility, I can move video signals. I can move audio signals. I can ingest from your digital automation system or your audio over IP system, and send it out to a transmitter site, or use it as a receive site and take all the ENGs that are on video based, and ingest 32 signals at one point and send it out to your switcher. So that's what you're seeing here, is us being able to, this is Chicago, where we can send out via different links to different locations, whether it's sending out to a transmitter site that's then an FM site that's then relaying out to a booster, or sending out to sending video out, ATS3, ATS1, or even just going out to a translator. We have, again, because we're just sending IP, however you get the IP there, we don't care. Like I said, we have stations running baseband 192 on Viasat. So they're running composite, satellite, or composite over satellite. Like I said, I can't wait till the Musk stuff comes out, because I think that's just going to be a game changer for broadcasters in general.
Yeah. So what I as we were kind of mind mapping this, what this graphic looks like, we started saying, oh man, I've got a couple projects that we worked on where it was, main site to a booster site, or main site to 3 or 4 low powers. Maybe they're low power, FMs or HD radio applications or single frequency networks, or, whatever it might be, translators and so on and so forth. What we kind of captured here is, and what we're saying is, guys, we don't know what your topography looks like. You do. And I've had probably 2 or 3 phone calls in the last week where engineers have sent me sketches, and you guys have all done it, and that's kind of the fun of the product is, come to us with that challenge, and then we'll turn it around and kind of show you how it plays in, because it works with HD radio, it works with synchrocasting, what was it? Geo broadcast. Help me out here, Tony.
Whether it's a zone casting
Zone casting or max casting or whatever it might be, there's all these different various applications. So
application we just sold out for Bangladesh is they're actually going to use this for remote for I guess their soccer stadiums or their football stadiums, where they have 10 different languages being broadcast, and they're going to use this to accept the 10 different languages and send them out as IceCast to their CDN, and then give subscriptions out. So now they have one box that will be able to hold all the audio for everything and send it out as an IceCast to an IceCast server, and then off it goes to the 10 different whatever CDNs are going to use, and then whatever player they want to use, because at that point they can use any player. It doesn't need to be a device. It could be a computer or your phone or whatever.
Good. So when we talked about the how to use it, some other what that ecosystem looks like, because we really tried to go back and say, okay, how do we make it easy to implement? There's a lot of IP link users. That's great. How do we maybe repurpose those if someone's looking to upgrade or whatnot? So what are we looking at for the ecosystem of products?
Entercom has really embraced, and this is something Nick and I worked on a lot at the end of the year, and Kimberly, they've really embraced the Ascent, knowing that now they can have these devices that will ingest their live wire or their WheatNet and send out to all their transmitter sites, their main site, their backup sites, translators, boosters, with RDS, with E2X data if they needed to do that. So this has been an easy plug and play where they could take their IP links, and then, because we'll talk to an individual IP link out at the far end, we don't care. And because we're LiveWire Plus compliant, we'll be WheatNet compliant. That means we're able to transport contact closures with the LiveWire, with the WheatNet. So you can have a device within your audio over IP network command something on the far end running through the Ascent, if you would. So what you're seeing here is, whether our transport mechanism, whether you're using the Ascent or the IPL, our HD link is a 1, 2, or 5 watt RF transmitter. User selectable. It's a UDP radio. That's all it is. It at 256 QAM, it'll run 3.2 meg worth of UDP data. So that is more than enough to run composite with E2X data and whatnot. And that's basically could be used as a transport path. And then at the receive end, or you can use satellite if you want, and or cellular. I have a Max Connect here. Max Connect is through Bond Engineering. That allows. Basically, he gives you a fixed APN through your carrier of choice, either through AT&T or VZW. You're guaranteed bandwidth. You're guaranteed a fixed IP address, and you get a high priority APN. So for us here, like in South Florida, on a peninsula that gets surrounded by a lot of water and hurricanes and whatnot, the minute a hurricane's announced in this area, all the cellulars get dumbed down, so you can't make a call and all your data stops. But with the Max Connect SIM, we're guaranteed throughput. We're just below the 911 threshold, if you would, or a first network. So you can use that to pass audio over IP. And of course, the different series that we have, the IP Link series, very basic entry level, then a 2-channel one, a composite box, as well as then an enhanced 1-channel. Right below that, the 100C, that will be out next month, I believe. Kimberly, is that right? Is it next month? I think it's out next month. right?
Yeah,
Next month, or it's the 100C is the compact. So it's a half rack, runs on, has all the same features as our rack mount version. 3 Ethernet ports, all three can transport data as well as management. GPIOs, can run SRT with UDP and RTP, can run GPIOs and RS-232. Has a USB port on the back of it, so you can put a playlist on it if you needed to use that. But the inputs are mic line selectable. So now this is real simple to take out to a remote, throw it on, throw a 4G SIM on it somehow, or through some Cradle Point box or what have you. We did not want to build those in because you find that you go with Verizon, then you don't want, no one wants to use Verizon, they want to use AT&T. You go with AT&T, then someone wants to go with T-Mobile. So we thought better off let you guys get your own SIM and whatever your GM can trade at the time, and use that. And then the IP Connect, we'll talk about that in a second. The IP Link 100E, that is basically the IP 100C, but it fits in our exciters. It slides right in the back, uses the power from the exciters. Still 3 Ethernet ports, RS-232, and it's bidirectional. So not only can you send audio, receive audio through it and composite whatnot, you'll be able to send audio back out as a confidence monitoring. The Ascent Media Gateway, which we spoke about, the IP link or the HD link, again, 125 watts on TPO. It is a UDP transport. Those are just rock solid. They've been around forever and they just work great. Matter of fact, I think the new version coming out is we just don't put audio cards in anymore because everybody's using an IP link for a codec. No reason to put audio cards in there. And then the IP Connect. If you're looking for a way to transport information from A to B with all the features that you could do with an IP link, but it's not audio, use IP Connect.
Yeah.
It gives you the ability then, if you're looking for critical information that you want to take stream splicing and use multiple paths, this has dual power supplies. Again, just like an IP link, dual power supplies, 3 Ethernet ports, GPIOs. It gives you the ability. It has dynamic stream splicing included, so you can have multiple paths. And again, we'll ingest anything, turn around, and send it out the door. So this could be mission critical stuff. The bandwidth on this is not video bandwidth. I can't put 50 meg through this. This is good for mission critical if you had to get back and forth between a particular town or a studio and you're doing compressed video or whatever. I think the bandwidth limitation on this is 30 meg. So that gives you the ability then to give you that secure connections and multiple paths, but no audio codec. Maybe you have a codec of choice that you love right now. It starts with a B and it only costs you like $200. But it has no security and it's not reliable. You can actually connect that to this, and this would be the secure end for it. This would actually secure the transport between your favorite little codec and whatnot. Those are very popular for fire life safety and whatnot. Multiple time two-way radio plans together and whatnot.
Good. So, I think we kind of gave you guys a lot of information all at once, but the important thing is as we look at it, it is an ecosystem. You can add to it as needed. Migrate boxes around as your design side, the studio side changes. So, some of the benefits we talked about, simplicity. We didn't really get into the HTML dashboard. I just kind of show you a snapshot of it, but we've got that. SNMP integration, so any of your remote control stuff. Quality of service tools are an added feature, so you can really see kind of what you're paying for. Are you getting the service that you're paying for? And then the multiple codec options. It's flexible, point to point, point to multi-point, multi to multi, meaning like some of the stuff we did for some of the satellite audio guys, pushing audio around different plants to multiple destinations. And then, it definitely can grow with the expansion there. Built-in value. So all of these products can come with multiple, power supplies and stuff like that. So there's redundancy, different codec options, all these multi-codes in one source. And then, as always, we're based in Quincy, Illinois. We've got our engineers in Mason, Ohio. So there's local support. Tony's got a lab in his house now. So be careful how much you want to bug him, but that's what's cool about it is, we're trying different stuff out, making sure that everything works and experimenting as much as we can. And then, the integration side of it. So I thought it was really cool. A lot of stations that I talked to, after we're talking about transmitters, the next thing is how are we going to get the signal out to the transmitter? And so this really makes it easy and flexible, because now you can just put this one STL card right in the exciter, and away you go. So it makes it a little more simpler on the integration side. And then all these different audio types: AES, Livewire, WheatNet, and then it's also compact and it's standalone. So what does that all get you? At the end of the day, the way we see it is, there's a big return on investment here. Reduces expensive dedicated circuits. One of the groups that we worked with, I think the price that they paid for the package for all of their stations and sites, after we got done working through it, I said, so what did you guys save? And the VP of engineering I was talking to, he said, it pays for itself as soon as we install it. I was like, really? He goes, yeah, we changed all of our connection types and rebrokered all of our lines, and the price that we're paying for the equipment, we're going to save immediately because of doing this. So I thought that was pretty cool. Other than that, it limits the on-site maintenance, because all of us are sitting here in front of a computer to do the Zoom call. Well, guess what? Everyone now gets to maintain the equipment remotely through the GUI of these devices. So localized monitoring control. Some of the larger radio groups and television groups out there, they're remotely monitoring everything from one central NOC. So now this plays right into that. And then there's also, expansion, and then the layers of security.
So what we've had to develop for the three-letter agency guys, all the security and everything that we had to put in, broadcasters have full benefit of it. And we people are like, oh, we got to put these behind firewalls. No, it's okay, because we create our own little tunnel between the two units. When they communicate and they lock in, we have a secure tunnel. You've read about people hacking barracks boxes, but you've never heard anybody hacking an IPL link or T1 box ever. Now that I said that, some smart kid's going to be out there. But so that's, we are very aware of the security that we need to have in there to make sure, and the reliability. I mean, it's just, we need to be 5 nines.
So that being said, if you try it or have tried it or need a new software version or whatever, because this stuff is getting updated all the time, reach out to support. Tony,
send me an email.
Send Tony an email, or send me an email, and I'll put someone on it. And
let's put it this way: we our coders for the lead coders for IP Link. Her name is Hema. She sits in Mason. Or no, yeah, she sits in Mason, and Gavin, who is the lead guy on the Ascent, sits in Mason. And when we need something done, I call Mason. I'm not calling Latvia or some Russian country or somewhere and trying to get some code done. It'll take 10 weeks. They're right there, to the point where I sent version 3.17 out of IP Link today to a customer in California, and as I'm sending it out, 3.18 comes out. I'm like, hang on. And it was because she found something in 3.17. Not that no downtime or anything. It was something that she wanted to change, made the change, repackaged it, and had it ready to go that quick. And we're making improvements always, even though the IP Link's been around for a couple of years. It's not neglected. It is a very active, very current, very supported product. Just like we're counting on the IP Link and the Ascent to be married together.
Yeah, real good. So stay in touch, connect with us. I'm pretty active on LinkedIn. We've got new product releases, installs, training stuff that's coming up, current events, all that sort of thing. I'll open it up to you guys.
So what kind of device do you need on the other end? Like if you're doing, so when you say live wire streams, you're talking about like individual live wire streams, correct?
Well, no, this is this acts as a node on your network.
It does act as a node. Okay.
Yep. So it's going to be, except this has 8 channels, not 4. So it acts as an 8-channel node, and it would actually has the same it will have the same user interface, if you would, as their audio over IP driver.
So because of that, then what kind of internet connection? What's the size of the pipe that you need, basically?
Well, if you run Opus at 192, I don't know, 200K.
Okay.
Because what we're doing is ingesting, there's nothing special about Livewire or WheatNet other than, it's 25 microsecond packets or quarter second packets. So we're ingesting that information, and then we'll code it. We'll code it to, if you want to do uncompressed linear, 1.5 meg. You want to do, AAC, Opus, doesn't matter.
So it's Livewire, then it gets basically translated to be sent out, and then shows up again as Livewire at the other end.
Shows up however you want it to on the other end.
Gotcha.
If you're not talking to another Ascent unit that has Livewire in it, say your sister company is running WheatNet. Well, I can ingest Livewire and send it out WheatNet. I don't care.
Oh, okay.
Because all I'm doing is I'm just doing the translation in between. So, and if you're talking to an IP link, it's going to come out as either baseband 192 or it's going to come out as AS3 or left and right audio.